In this video, we are going to use the sample data of 10 rows from the automobile dataset and make two clusters from it using the Euclidean distance. First step is to randomly pick two rows as cluster centroids. Let's pick row 1 and row 5 as the initial cluster centroids. Think of these centroids as two separate clusters. One by one, we would calculate the Euclidean distance of each of the rows with these centroids. The row would become part of that cluster which is near to it. We will start by calculating the Euclidean distance of the two centroids with row 1 and row 5. Since first centroid is row 1, the distance between them would be 0. So, row 1 would become a part of the first cluster. Similarly, since second centroid is row 5, the distance between them would also be 0. And as a result, row 5 would become a part of the second cluster. Although this is obvious, we are doing this step to understand that cluster centroids and each of the rows are considered separate entities. And we therefore need to calculate the distance of the centroids with each of the rows and assign each row to one of the two clusters. So as the first step, let's calculate the distance of the two centroids with row 1. As already explained, row 1 would be assigned to the first cluster. We need to update the cluster centroid since cluster 1 now has two elements. One is the initial cluster centroid and second is row 1. This is done by calculating the average of length, width and height of the initial cluster centroid with the respective length, width and height of row 1. Since cluster centroid 1 and row 1 are the same, the average value would remain the same as the initial cluster centroid. Now that row 1 has been assigned to the first cluster, we'll pick the row 5. Since second cluster centroid was row 5 would become part of the second cluster. And after updating the cluster centroid, we would end up with the same value of second centroid as we had before. Before calculating the distance for the rest of the rows, let's review what we are doing. Our 10 rows of data contain 3 variables, namely length, width and height. For making two clusters from this data, we randomly picked two rows as cluster centroids. Now, we need to pick each of the rows in the data one by one and calculate their distance with the cluster centroids. Each row would be assigned to that cluster which is near to it. Let's also review the formula of calculating Euclidean distance. To calculate Euclidean distance between any row and a cluster centroid, we need to follow certain steps. First, we would subtract length in the cluster centroid from the length in that row and square the difference. Similarly, we would subtract width in the centroid from the width in the row and square it. Finally, we would subtract height in the centroid from the height in the row and square it. After this, we are going to add the 3 squared differences and find the square root of the resulting value. This square root value represents the Euclidean distance between the cluster centroid and any given row. Just to point out, inside R, a single line of code is enough to make as many clusters as you want. For once, I am explaining the whole process step by step for better understanding. Let's get back to the task at hand. We have already assigned row 1 and row 5 to their respective clusters. Now, we are going to take each of the 8 remaining rows one by one and find their distance from each of the cluster centroids. We will now pick row 2. As you can see, row 2 is closer to the first cluster. We therefore need to update the first cluster centroid by finding the average of the length, width and height in the first cluster centroid with the respective length, width and height of row 2. The updated value of first cluster centroid after taking the average is this. Note that the second cluster centroid would remain unchanged till any of the remaining rows become a part of it. Next, we are going to take row 3 and find its distance from the updated cluster centroid 1 and unchanged cluster centroid 2. Based on Euclidean measure of distance, row 3 is closer to cluster 1. Now, we are going to update the cluster centroid by averaging out the length, width and height of the first cluster centroid with the respective length, width and height of row 3. The first cluster centroid is now represented by the following values. Now, we will pick the row 4 and calculate its distance with the two cluster centroids. Again, row 4 is closer to the first cluster. After updating the first cluster centroid, we would get the following value. We have already included the row 5 to the second cluster in the beginning. So, we will move to the row 6. Based on the calculated Euclidean distance, it is closer to the first cluster. The first cluster centroid would therefore be updated to this value. Next, row 7 is again closer to the first cluster centroid. So, we will update the first cluster centroid to get the following value. We are left with 3 more rows of data that are yet to be assigned to any of the clusters. Let's now move to the row 8, which is again closer to the first cluster. So, we will update the first cluster centroid once again. As you can see, the choice of the initial cluster centroids are causing all the rows to move to the first cluster. If instead, we would have picked a row other than row 5 as the second cluster centroid, the two clusters might have been more balanced. But as of now, each of the rows are becoming a part of the first cluster. Moving on, we are left with row 9 and row 10. Row 9 is again closer to the cluster 1. So, we will update the first cluster centroid to get this value. Let's now move to the last row and calculate its Euclidean distance with the two centroids. While the first centroid is being updated every time a row is joining the first cluster, the second centroid has remained unchanged, since none of the rows have been added to the second cluster. Based on the calculated Euclidean distance, we finally have a row that is closer to the second cluster. Now, we will update the second cluster centroid for the first time to get this value. Let's look at the outcome of the clustering process. We have 2 rows that are part of the second cluster and 8 rows that are part of the first cluster. After the completion of the clustering process, the first cluster centroid is represented by the following values of length, width and height. In the same manner, the second cluster centroid has the following values for these 3 elements. In the next video, we will visualize the two clusters in a scatter plot.